Hello, in this video let us discuss inverse of a 3 by 3 matrix. Let's say we have this 3 by 3 matrix right here and we have the elements inside. Don't get confused, the values or the subscripts only refers to the rows and columns of the elements. For example, A11 means the element in the first row, first column. First row, second column, first row, third column, and that's it. And to find the inverse, we have this formula. The inverse is equal to 1 over the determinant of matrix A times the adjoint of matrix A. Just in case you're not familiar with solving the determinant of 3 by 3 matrices, I highly suggest you watch my video for that. And for the adjoint, we need the cofactors and the transpose concept because the adjoint is equal to the transpose of the cofactors. We also made a video about cofactors, minors, and transpose. And if you haven't watched that yet, I highly suggest you watch it first because you're going to have a hard time following this video without knowing this. With that being said, let's proceed to solve some example problems. Let's consider the following 3 by 3 matrix. Okay, now the first step to find the inverse of this 3 by 3 matrix is to solve for the determinant. So, the determinant of matrix C is equal to, you know the process of solving for the determinant of 3 by 3. Let's copy first. And then we will copy the first two columns outside. 1, 0, 5, and then 2, 1, 6. We will apply the basket method. Let us multiply diagonally downwards from left to right. So, the determinant of C is equal to 1 times 0, that's 0, plus 2 times 4 times 5, so that is equal to 40, plus 3 times 0 times 6, still that's 0. And then minus, multiply diagonally upwards. 5 times 1 times 3, that's 15, plus 6 times 4 times 1, that's 24, plus 0 times 0, so that's 0. Okay? So the determinant, 0 plus 40 plus 0 is 40, minus 15 plus 24, that's 39. And 40 minus 39 is equal to 1. So the determinant of matrix C is equal to 1. Okay, looking back at our formula, we need the determinant and the adjoint. Okay? So, the next step is to solve for the adjoint. And to find the adjoint, we need the cofactors. Alright? And the idea here is to find the cofactors, we must find first the minors. So the minors, let us solve, of matrix C. The minor of the element in the first row, first column, is this, the determinant of the remaining 4 elements. So the determinant of these 4. So 1 times 0 is 0, and then 6 times 4 is 24. 0 minus 24 is negative 24. Next, let's solve for the minor of the element in the second row, first column. And then we have to find the determinant of the remaining 4 elements. So 2 times 0 is 0, 6 times 3 is 18. 0 minus 18 is negative 18. So negative 18. Next, the minor of the element in the third row, first column. So we have these 4 digits or 4 elements. 2 times 4 is 8. 1 times 3 is 3. So 8 minus 3 is equal to 5. Next, the minor of the element in the first row, second column. So we have these 4 elements. 0 times 0 is 0. 5 times 4 is 20. And 0 minus 20 is negative 20. Next, the minor of the element in the second row, second column. So we have these 4 elements. 1 times 0 is 0. 5 times 3 is 15. And 0 minus 15 is negative 15. Next, the minor in the third row, second column. So we have these 4 elements. 1 times 4 is 4. 0 times 3 is 0. So 4 minus 0 is still 4. Next, the minor of the element in the first row, third column. So the determinant of this 2 by 2 matrix. 0 times 6 is 0. 5 times 1 is 5. And 0 minus 5 is negative 5. Okay. Next, the minor of the element in the second row, third column. We have these 4 elements. 1 times 6 is 6. 5 times 2 is 10. And 6 minus 10 is negative 4. And lastly, the minor of the element in the third row, third column. So we have these 4 digits or 4 elements. 1 times 1 is 1. 0 times 2 is 0. And 1 minus 0 is 1. Now we have completed our minors matrix. And using this minor, we can find the cofactors. The cofactors are basically the minors, except for some sign variation. If we use the rule of signs for 3 by 3 matrix, let's follow. So this negative 24 times positive, look at the relative position. So that's negative 24. Negative 20 times negative becomes positive 20. Negative 5 times positive, that's negative 5 still. Negative 18 times negative, so that becomes positive 18. Negative 15 times positive, still negative 15. Negative 4 times negative becomes positive 4. 5 times positive, so 5. 4 times negative, negative 4. And then 1 times positive is positive 1. And therefore, we now have our cofactor. And the only thing that we have to do is to find the transpose of the cofactors, okay? Using the formula for adjoint, so the adjoint of matrix C is equal to the transpose of cofactors. And when we say transpose, we have already discussed it in a separate video. It means we will swap the positions of the rows and the columns of the cofactors. For example, so in our cofactors, the first row has the elements of negative 24, 20, and negative 5. Now, in our adjoint, since we have to transpose this cofactor, this first row elements becomes the first column elements. So negative 24, and then 20, and negative 5. Next, the second row elements become the second column elements here. So we have 18, negative 15, and 4. And lastly, the third row elements become the third column elements. So we have 5, negative 4, positive 1. Next, we can now find the inverse. So the inverse is equal to 1 divided by the determinant of C. As you recall earlier, we have solved that. The determinant of C is equal to 1. And then multiplied by the adjoint, and the adjoint is this matrix. Negative 24. And since 1 divided by 1 is equal to 1, we can say that this is the inverse. Okay, so we can just ignore this part. So this is the inverse. Next, let us consider another 3 by 3 matrix. Okay, first step is to solve for the determinant. So the determinant of matrix D is equal to, let's copy. We have to copy the first 2 columns outside. The determinant of matrix D is equal to, let's multiply diagonally downwards from left to right. 3 times 0 times 1, that's 0. Plus 0 times negative 2 times 0 is still 0. Plus 2 times 2 times 1, that's 4. minus, multiply diagonally upwards. 0 times 2, that's 0, plus 1 times negative 2 times 3, that's negative 6, plus 1 times 2 times 0, still 0. Therefore, the determinant is equal to, this is 4, and then minus negative 6. 4 plus 6 is equal to 10. So the determinant of matrix D is equal to 10. Now it's time to solve for the minors. The minor of the element in the first row, first column, is the determinant of this 2 by 2 matrix. So 0 times 1 is 0. 1 times negative 2 is negative 2. 0 minus negative 2 is positive 2. Next, the minor of the element in the second row, first column, is the determinant of the remaining 4 elements. 0 times 1 is 0. 1 times 2 is 2. So 0 minus 2 is negative 2. Next, the minor of the element in the third row, first column, is the determinant of these 4 elements. So 0 times negative 2 is 0. Minus 0 times 2 is still 0. So we have 0 over here. Next, the minor of the element in the first row, second column, is the determinant of the remaining 4 elements. So these are the 4 remaining elements. 2 times 1 is 2. 0 times negative 2 is 0. So 2 minus 0 is still 2. Next, the minor of the element in the second row, second column, we have 3, 2, 0, 1. So 3 times 1 is 3. Minus 0 times 2 is 0. We have 3. Next, third row, second column, we have these 4 elements. 3 times negative 2 is negative 6. 2 times 2 is 4. Negative 6 minus 4, that's negative 10. Next, the element in the first row, third column, we have to find the determinant of this 4. So 2 times 1 is 2. This is 0. So 2 minus 0 is 0. Rather 2. Next, the element in the second row, third column, we have these 4 remaining elements. So 3 times 1 is 3. 0 times 0 is 0. So we have 3. And lastly, the element in the third row, third column. So let's multiply. 3 times 0 is 0. 2 times 0 is 0. So we have 0. And now it's time to find the cofactors. For the cofactors, the values are the value inside the minors, except that we have to change some of the signs using the rule of signs for 3 by 3. So this positive 2, following the rule of signs, still remains as positive 2. Positive 2 becomes negative. And then positive times 2, so still positive 2. Negative 2 becomes negative, so that's positive 2. And 3 times positive, so still positive 3. Negative times 3, so negative 3. And then 0, these zeros remains zeros. And negative 10 times negative becomes positive 10. So this is our cofactors. All right? Now we can solve for the inverse of matrix D. So the inverse of matrix D is equal to 1 over the determinant. 1 over determinant, and the determinant is positive 10. Okay? Times the adjoint. So the adjoint is the transpose of this cofactor. And the transpose of these cofactors, let us try. The first row becomes the first column. So 2, negative 2, positive 2. Next, the second row becomes the second column here of the transpose. So 2, 3, negative 3. And the third row becomes the third column. 0, 10, 0. And finally, we have to distribute 1 over 10 to each of the elements inside by scalar multiplication. The inverse is 110 times 2, that's 0.2. 1 over 10 times negative 2, that's negative 0.2. 1 over 10 times 2, again, is 0.2. 1 over 10 times 2 is another 0.2. 1 over 10 times 3 is 0.3. 1 over 10 times negative 3, that's negative 0.3. 1 over 10 times 0 and times 0, so we have 0 here, 0 here. 1 over 10 times 10 is 1. There you have it. This is our inverse of the matrix D. Let us try one more. First, let us solve for the determinant. Let me copy. Next, copy the first two columns outside. Let's multiply diagonally downwards from left to right. 2 times 0 times 8, that's 0, plus 1 times 2 times 4, that's 8, plus 3 times 1 times 1, that's 3, minus, multiply diagonally upwards. 4 times 0 times 3 is 0, plus 1 times 2 times 2, that's 4, plus 8 times 1 times 1, that's 8. Let's simplify. 8 plus 3 is 11, minus 4 plus 8 is 12. And 11 minus 12 is negative 1. So the determinant of the matrix is negative 1. Now let's go to minors. The minors of matrix N is the following. For the first element, the element in the first row, first column, we have to find the determinant of these 4 elements. So 0 times 8 is 0, 1 times 2 is 2, so 0 minus 2 is negative 2. Next, the minor of the element in the second row, first column, so like this, we have these 4 remaining elements. 1 times 8 is 8, 1 times 3 is 3, and 8 minus 3 is 5. Okay. Next, the element in the third row, first column, like this. So find the determinant of this 2 by 2 matrix. 1 times 2 is 2, 0 times 3 is 0. So 2 minus 0 is still 2. Next, the element in the first row, second column, we have these 4 elements. Find the determinant. 1 times 8 is 8, 4 times 2 is 8, and 8 minus 8 is 0. So next, the element in the second row, second column. So 2 times 8 is 16, 4 times 3 is 12, and 16 minus 12 is 4. Next, the element in the third row, second column. So we have these 4 elements. 2 times 2 is 4, 1 times 3 is 3, and 4 minus 3 is 1. Next, the element in the first row, third column. So we have these 4 elements. 1 times 1 is 1, 4 times 0 is 0. So 1 minus 0 is 1. Next, the minor of the element in the second row, third column. So we have these 4 elements. 2 times 1 is 2, 4 times 1 is 4, and 2 minus 4 is negative 2. And lastly, the minor of the element in the third row, third column. So 2 times 0 is 0, 1 times 1 is 1. 0 minus 1 is negative 1. Now we can go to the cofactors. For the cofactors, we will use the minors and then adjust the signs using the rule of signs. Negative 2 times positive, still negative 2. 0 times negative, still 0. 1 times positive, still positive 1. 5 times negative is negative 5. 4 times positive is 4. Negative 2 times positive, rather negative, becomes positive 2. 2 times positive is positive 2. 1 times negative is negative 1. And negative 1 times positive is negative 1. Therefore, this is our cofactors. Now, we can now solve for the inverse of our matrix N. So the inverse is equal to, following the formula, 1 divided by the determinant of matrix N, which we have solved earlier, which is equal to negative 1. And then times the adjoint of the adjoint matrix. And the adjoint matrix, according to the formula again, is equal to the transpose of the cofactors. So let's transpose these cofactors. The first row becomes the first column, so negative 2, 0, 1. The second row becomes the second column, so negative 5, 4, and 2. And the third row becomes the third column, 2, negative 1, negative 1. And 1 divided by negative 1 is equal to negative 1. So we have to multiply negative 1 to each of these elements inside. And finally, the inverse of matrix N is, so negative 1 times negative 2 becomes positive 2. Negative 1 times negative 5 becomes positive 5. Negative 1 times 2 is negative 2. Negative 1 times 0 is still 0. Negative 1 times 4 is negative 4. Negative 1 times negative 1, positive 1. Negative 1 times 1 is negative 1. Negative 1 times 2 is negative 2. Negative 1 times negative 1 is positive 1. And there you go. This is the inverse of the given matrix.